Good afternoon and welcome to Think Purple Math. Today's topic is the segment addition postulate. You notice on the screen that you see next to me a little bit of a definition about what the segment addition postulate represents. If you have a point B that lies between AC on a line segment, then the segment addition postulate is listed there in the purple box that AC is equal to AB plus BC. And that can be represented in several different ways, a few different ways, algebraically and in words, what have you. If you look below on the bottom third of the drawing on my sheet there, below the second purple water line, you'll see a line segment divided up A, B, and C. A, B is equal to X length, using the variable to represent, and BC is being represented by the length Y. If you notice down on the very bottom there in green, what that total picture is represented is AC is equal to the length X plus Y. X is AB and Y is BC. That's another variation of the segment addition rule postulate. So what we're going to do is we're going to take a look at 6 sample problems to help us understand a little bit more about segment addition. And the first, and these are divided into 3 typical sets: set 1, set 2, set 3. And the levels go up each time. So set 1, here's problem 1. Find the length indicated, find HG. I notice that on my drawing there that HG has a question mark. We're missing that amount. GF segment is 2. And you notice the second line says 10 inches. That represents HF, the whole piece. So what we're going to do is we're going to solve this by using segment addition. And the first problem we do is at a very low level, not very difficult. We're going to write out the segment addition. HF is equal to HG, or the length of HG, plus the length of GF. We're going to substitute what we know and solve for the remaining answer. HF happens to be 10. HG is question mark, but we're going to leave HG in the expression or the equation. GF was given to us, and that is 2. So that means that HG plus 2 is equal to 10. We're going to use mental math and determine that HG is 8. And since we have a unit listed there, to be more correct, we're going to always make sure to label our unit. HG is 8 inches. So that's a look at segment addition, and now we're going to do a few more to help us understand a little bit better. Here's one. We have 3 segments joined together. The entire segment is IL. And it's made up of 3 segments, IJ, JK, and KL. The entire unit, the entire segment is 26. So that means that IL is equal to IJ plus JK plus KL. And the segment addition can have more than 2 segments being added. Could be several of them. In this case, there's 3. All right, we'll plug in what we know, that IL is 26. IGL is 9, located in red. We're looking for this piece. It's in the question mark. JK is 11. And KL, we do not know. But we're going to find out here in a minute here by doing some arithmetic. 9 and 11 would be 20 plus KL. So 20 plus KL is 26. We're going to use mental math, and we're going to see that KL is equal to 6 units long. There is no unit of measure there, but we understand that it's 6 for this case. Okay, our next step, there is a word problem, a mini word problem, to represent a situation. And I'll read this here. point A, B, and C are collinear. So we have point A, B, and C on a straight line. They're on the same line. Collinear means that they are on the same line. Point B is between AC. Find the length indicated. So we're looking for AC. So we have an A, a C. AC is the entire unit. But notice here that has AB is 16, BC is 12. Therefore, AB is slightly larger. Let me do that just a little bit better here. That AB is slightly larger than BC. So we're going to represent this drawing, this statement, this situation algebraically, numerically. AB is 16, BC is 12. We'll go down below the water line and finish this particular problem. We're going to state the addition formula postulate. AC is equal to AB plus BC. AC is equal to AB, which is 16, plus BC, which is 12. We do some mental math. We find that AC is 28 units. So in some ways, the segment addition, you have to subtract part of the segment off to get the remaining piece that you're looking for. In this case, we're actually adding the two sections. So 28 is your final answer. Okay, our next one, the drawing represents the statement above. Find BC, which is where X is, AC, which is 22, which represents the green, and AB is 13, which is in red. So in a nutshell, AC is equal to AB plus BC. And sometimes you'll have X, Y, and Z, and that's the same. These are the letters that are more common, A, B, and C. So AC is 22, AB is 13, BC is unknown, but we're going to leave it as X because it's being represented by X. So we see that 22 is equal to 13 plus X. Using mental math, we find that X is equal to 9. But more importantly, we want to represent the answer that BC is equal to 9. So X represents the length of BC. And that's using a simple algebraic expression. Okay, we got a couple more, a little more intense. Okay, here's one that has a drawing listed there. The entire segment AC is 3x plus 3, represented in blue. AB is negative 1 plus 2x, and BC represents 11. So if you started to catch on with what the segment addition rule states, postulate, the blue is equal to the sum of the two red segments. So that means that AC, in fact, we're just going to put in the algebra. 3x plus 3 is equal to negative 1 plus 2x plus 11. We'll do some arithmetic here, algebraic solving. Combine like terms, we'll start out in that fashion. We're going to subtract 2x on both sides. We'll get x plus 3 is equal to 10 when I subtract 2x. And we're going to use mental math to find out that x is equal to 7 by applying the segment addition postulate. X is equal to 7. Okay, we have one more for the road. And we'll be done with this lesson, this little topic, segment addition postulate. Here the same thing occurs. The blue is equal to the sum of all three red algebraic expressions. So we're going to set up our water line and go below. 4x minus 29 is equal to 2x minus 18 plus 13 plus 6. So I've set it up correctly. We're going to do some arithmetic here. We're going to end up with 2x plus 1 when we combine like terms. I'm going to subtract 2x on both sides, and you would get that. Now I'm going to add 29 to both sides. 2x is equal to 30. I'm going to divide by 2, and mentally we're going to get x is equal to 15, and that would be your final answer. So in this case, the segment has been broken up into 3 smaller segments, and they combine into the entire piece. X is 15. Well, anyway, that's a look at segment addition postulate. Anytime you have questions, if you happen to be one of my students, please stop by. Let me know. I help you out. If you want to see something put up online, I will do that for you. All right, so go ahead and make sure to always think Purple Math, and have a great day. And